So we'd use a power rule on the first one, the f, and so that just becomes 2, right? Because you bring down the 1 and the x goes away. Do you want to see that detail? It becomes 2x to the 0, which is just 2.
Yep.
And then g prime is another chain rule, because we want to take the derivative of ln, but there's a function inside of ln. So this is kind of similar to the other side of that chain rule, where we had an ln with a function inside of it. So it's also a chain rule for that same reason. And so this becomes the chain rule, which is this one right here. See how the chain rule on the left here has a function inside of another function? There's an f and there's a g inside of that f. So that's how we identify a chain rule. And what the chain rule says to do, it says take the derivative of the f function, leave the g function alone inside of it, and then multiply by the derivative of the g function. And so with the chain rule in mind, our f, our outside function, is the natural log, and the inside function is 2x. You kind of see how this applies there with those two things?
Yes.
Sort of pause right there. Seems okay?
Yes.
So then we take the derivative of that, right? We want to do f prime with g inside. So f prime with g inside. You know the natural log derivative, what that becomes? Just
No,
becomes a 1 over x.
Yeah, okay.
Right? So let me get my notation straight, because right now it's not looking great. This is really, I'm just going to show you f prime with x first. And so the f prime with g inside then is this. That's okay.
Okay.
And then g prime is another power rule, right? Just becomes 2. And so I know that's like a little aside. Sometimes the chain rule is kind of complicated. And so sometimes you need a little aside there. And so when I go back and kind of write the final g prime here, it's f prime of g of x. So that's 1 over 2x times g prime. All right, here's my f prime with g inside of it. I'll run out of space times my g prime.
Okay.
And so that's the right side of that first equation. So that's we started with the product rule, and then inside of that product rule ended up being a chain rule, right? This g prime ended up being a chain rule. And so that's how these derivatives oftentimes go. It's like you identify the first rule, and then once you get into that rule, sometimes you have rules inside the rules type things. It could happen in the quotient rule. It could happen in any of the rules, really.
Okay, yeah, that's clearly what I need to work on, is just seeing that rule within a rule.
Yeah,
Mhm.
that's what got me in the last test was this function inside of a, I guess it's a function inside of a derivative or a function inside of a function.
So yeah, they're called composite functions, and that they can definitely be tricky if you're not familiar with them. Could you want to do a quick little aside about composite functions?
Yeah,
Sometimes-
I don't mind. So I understand that I haven't been in school in 20 years, and I just got thrown into calculus. So
Okay. So you didn't do like I don't know, some brush up course or pre-calc before this or anything like that?
I did pre-calculus, but that's still, it's 8 weeks of pre-calculus after 20 years of nothing.
Mhm.
So I was barely getting my algebra together, and I'll never
Okay.
forgive my whoever signed me up for these classes first.
Yeah, it's definitely tough coming back. I would recommend some algebra sometimes first, but it depends. Some people can pick it up quickly.
Well,
Or sometimes.
my next class is algebra.
Okay, that's interesting that calc
Yeah.
comes first. What is the next class called? Do you know? I'm not familiar.
I think, as I believe, it's just algebra.
Is it a 100 level class?
I believe so. Yeah.
Well, you're gonna fly through that.
Well,
I was gonna say that class usually probably comes before this one and probably before pre-calc too, but I don't know.
I needed pre-cal and calculus before I could take my computer science classes. Those
Right.
are required. But I
Yes.
need algebra just in general to graduate. So they put my
Okay.
pre-cal and calculus so that I could go ahead and get into my computer science courses. And then they just said, well, we'll do algebra whenever. And then that's what I'm doing next. So it's
Gotcha.
a lot of fun.
Yeah. After you do the algebra course, you might look back on some of the stuff and be like, oh yeah, now I see where that stuff came
Yeah.
from.
Thank God.
Let's talk about composition functions just quickly though. Sometimes I'll just do this demonstration. Like, let's say our f of x is x squared plus 2x plus 1. Let's say our g of x is, I don't know, e to the x. And let's also just pick out a h of x, cosine of x. We can do stuff like plug them into each other. And I usually do this in color coded to kind of help with that. So you can do things like, how about we do f? Oh. So first of all, you know how to do things like f of 2, right? Everyone knows that f
Yeah.
of 2 just means you take out the variable and you put in a 2. But I'm going to be real deliberate about it here because it's the same. It's the notation. This is like a notation thing. And I like to say this too a lot in math classes. Once you get into calculus and beyond, a lot of understanding is a lot of algebra and stuff like that, but it's also notation. Like, what does those symbols mean? And what are the combination of them asking me to do, really, right? So
Yeah.
so and I hope this kind of demonstration helps with that sometimes. So anyway, so f of 2, let me actually start over. F of nothing is when there's nothing in there, right? It's like we started with f of x, but then you take the x out. And so we took it out everywhere, right? We just kind of like delete it.
Mm-hmm.
And then when you do 2, like plug a 2 in, you replace the 2 or the x with the 2. So you like fill in the gaps. And so the notation when you do something like, let's do f of blip. One of my colleagues likes to call this f of blip when there's nothing in there. There's nothing in there. Let's plug g in this time. So we're going to put e to the x inside there. And so it's just going to go wherever the variable was. Right. And so that would be f of e to the x, also known as f of g of x, right? Because g is e to the x.
Oh.
Okay. Yeah.
Right. And you could do that. You could flip it though, too. You could do something like g of f of x. Let's do g blip first. Let me zoom out a little bit. So g blip would be like this. And then you could put other stuff in there, right? You could do g of f of x. And so it would be like x. I didn't leave myself enough room, unfortunately, but x squared plus 2x plus 1. Right? Because now f is on the inside of g versus g being on the inside of f.
Yeah, that makes a lot of sense.
And you could even do stuff like, without doing the color coding, you could do g of f of, we already know what that is, we just wrote it down. You could plug h inside there. So we just take what we just had, but now we put cosine into this one. And so that's where it could kind of get deep and funky or whatever, but recognizing something being inside another function is particularly important with the chain rule, but it's just generally helpful to understand when you see a notation that says,
So
so
just randomly on the very last one you did, if you were going to have to solve this, and no matter which one it is, you always start with the most inside and try to work that problem first and then go out. So you would try to do the cosine x and then work to the
no, you look big
x
picture
squared.
first. You look
Okay.
big picture. I see e raised to a power. There's a property that tells me how to differentiate e raised to a power. That's where you would start. Oh, I forgot I was on the same page. You would say, I don't have that property on this page. Is it on this one? Yeah, it's this one, right? It starts with this. You're taking the derivative of e raised to a power. But it's not an x in there. And so it ends up being a chain rule because it's if we kind of look at the chain rule again, we have f of g of x e to that. Let's just go back to this one, where the f, the outside thing, is e to
I
the
think-
x.
I think
Yeah,
I
go
get
ahead. Sorry?
I was just saying, I think I get it now.
Yeah.
Oh, awesome.
Yeah.
Right. So the inside part.
Recognizing it.
Okay.
So it's the opposite of sort of what you're saying. You think you
Yeah.
look at the outside, and then you say, okay, well, what it's an e to the something. What's the something? Okay, well, it's a function. So that's the chain rule. You just kind of you go outside and you work your way into it, really.
Okay.
Do we want to flip back? We got sidetracked from that original mastery exercise, which I may have lost track of.
Yeah, so it was
I do
2x
still have it
to the
here.
2x power in terms of natural log.
Yeah, I've got it here. Let me share my other screen. It's on my stop the iPad, start the computer. So what did we make it to? We made it to,
So I think we were on the right side evaluating. So there's 2x natural log of 2x, and we had to use the chain rule.
right. So what we just did on the other page was what I just boxed in there.
Yeah,
This is our f prime g, and here's our I'm getting confused. F prime g plus, yeah, here's the f, this is the f, and the g prime is the other part. And so I'm sorry, I keep switching between devices, but that's what I had on the other screen. They just combined the fraction together in there. And so they want, the goal here is to get s prime, right?
Yep.
You want s prime of x because we're trying to get the derivative. And so on the left side, the thing that we didn't look on the other page is doing the derivative of this is the exact same kind of chain rule, right? So that's a chain rule. We have f of g of x with our outside function being ln, and the inside function is s, right? There's like an s inside the ln. And so when we do the derivative, we do f prime of g of x times g prime. So that ends up being 1 over s times s prime. So that's how they get this thing on the left right there.
Okay.
So it's the same chain rule that gives us g prime. You see that there? G prime looks very similar to the thing I just wrote down. It's just we have numbers in there, and the other one on the left is just s. We don't know what s is.
Yeah.
We do know s is. We're going to plug it back in a second. I'm going to scroll down though, so I'm going to delete this because I'm writing on top of the screen. Does that seem okay?
Yes.
This is a particularly complicated one. I should just mention that too. So if this is like the one you got wrong or whatever, it's like, I wouldn't feel too bad about that.
Yeah. I think I got it wrong twice. I can't remember.
And so we've now completed this stage on the left, right? We've done this. And so again, we want s prime. And so we're just going to solve for s prime is what happens in the end there.
Okay, yeah. So I see that.
And so they just like move s over. And then they plug it back in, right? We know what s is. S had the equation at the beginning. It was the 2x to the 2x thing. And so they plug it back in right here. See, this thing became that. And then they just plug the 4 in. I would file this under the category of tricks mathematicians like to think up to work on hard problems, but not the kind of thing that I wouldn't call this a make or break kind of idea here. But having said that, if you kind of follow what we're doing, because involved, right? We did like the product rule, the chain rule. There was a natural log in there, so it was a log rule. There's
Yeah.
algebra and solving for it, and we plug stuff. So this is involved. If you kind of follow that, I feel like you've got a lot of the components there. Should we step back to a more basic one, or how does that feel? Does that seem okay?
Yeah, I feel better about the concepts in this one. Yeah.
You want to pop back to the other one you're asking about, or did you have a question you want to ask about, Jacob?
I do, but I don't even know if I just eventually we can get back to me. I had a problem where I thought that I might be crazy. And I just remembered it from last week. And it just I was completely stumped because I couldn't figure out it's actually in the interactive lecture.
Okay, I can pull it up too. Well, let's just look at that other one since I've got
Yeah,
this
yeah.
pulled up.
We can go back to me because I don't
Sure,
even
we can
know
look at
if
yours in
it's-
just one second. Maybe we should start with this other easier one. The other question you were asking about was 6,
Yep.
which at this point, what do you think about that as a rule? Like, what are we looking at there? Remember thinking outside, big picture thing.
Yeah, so we've got power rule, but also
Yeah, I didn't understand this
the
either.
chain rule.
So anytime there's the constant in front, we just like ignore it. So it's the constant rule, but we don't even really need to talk about that, right? In other words, when we do this, you just like ignore the 2 and you just do this is the way you kind of think about it.
Okay, so you just take okay, I see what you're saying.
That's literally what the
Bring it
rule
out.
says. Yeah, you just like pull it out in front, exactly.
Okay.
And that's a constant rule. I can switch over and show you that, but I'm sharing the wrong screen
No.
at this point. But let's keep going. So were you going to say something, Jacob?
I was going to say, no, I got the constant rule as well.
Okay, awesome. So this is similar to the one we were pointing at on one of the last ones, where it's an e raised to a function. And so we want to use the e rule, but it's another chain rule.
Okay, yeah. I've got like e raised to g of x equals e g of x times g prime of x.
Exactly. So it's an f of g of x, where f is e to the x and g is 5x. And so then f prime with g plugged in, the e rule is the easy one. It just stays the same. You don't do anything with e. It just stays the same. But we want the 5x in there. And then g prime is a nice power rule. And so we're going to do f prime of g of x times g prime, right? This is the chain rule. If you don't have a list of the rules, that would be a really nice reference thing to have. Right, so f prime of g of x, e to the 5x, g prime 5. I forgot about the 2 though. There's a -2 in front. And so it's going to end up being -10. I was like, where's that answer? I don't see it.
Okay, yeah, this one's I don't know why, a little more straightforward, but it is. The natural log thing really throws me off.
Yeah, the natural logs are tricky. It's similar to ease though, right? A lot of the time it's either easy, like natural log. If you just take the derivative of natural log, that's another kind of easy one. It's just 1 over x. You don't have to do a lot. But when there's something inside it, like this one, e to the x, something inside it, it becomes a chain rule. So anytime you have to do a chain rule, it's the worst rule, basically, right? You have to think about what's inside what. You think about them separately, but also together. It's confusing.
Yeah.
Should we pop over to the interactive lecture? Is that this one okay?
Yeah, I honestly, I just have a question to where either I completely missed something or the interactive lecture is
Was it in 4?
no, it's actually in 3. It's been bothering me for like 2 weeks at this point.
It could be an error. Someone else found an error in there at one point. I don't write these for the record. I just manage this. I think they're
It's
generally pretty good.
It's in module 3. I think on the second page where it says that I've got 9% done. So whatever that is, if you
Yep,
scroll
I'm on
all the way
9%.
down, if you scroll all the way down to where it's the quotient rule,
Uh-huh.
let me see, it's k prime x. Yeah, maybe go to the, so open the examples. So yeah, I was following this along and I come across that, you had it right, where the quotient rule was at. I was following this along and I don't know where 5x3 plus 2x plus 1 comes from.
Okay. F prime. Where does 5x plus 3 comes? It looks like they just put the wrong function in there or something.
Because I'm so new to this, I just take it all on faith. And so I was like, I had to have missed something. And it's just,
There's also this weird parenthesis thing going on down here. This should be like a small parenthesis, right? Like this square. Anyway, that's just
Yeah.
a small, that's a smaller issue. It's just F and G. Oh. Okay. This is what's going on. I got confused too. So first of all, I agree the 5 probably shouldn't be there, right? That it should be this function.
that's what I thought, but I don't know.
Yes, right, because you do h squared, here's h, here's h. It should be, and it is that function down there.
Yeah.
It looks like they just copied, like it's just a copy paste error. Because
Yeah,
it's
but that's why I was looking up. I was like, did they copy and paste it from another problem? I don't know where
it's
it
the
was.
same function.
So this one is a little bit trickier because it's a quotient rule because it's a fraction,
Yeah.
right? But then you end up doing the product rule in the top. So when you do the derivative of the top, this part right here, that's a product rule. And so you do, let me just make sure, maybe they multiplied something through. You do f prime. This is only the first step too. Yeah, see, now it's back to the other function. Yeah, that's a typo.
Is it just a misprint? And I've just been like, it's one of those, like, I'm not crazy, right?
No, yeah, you're not crazy.
Okay.
Thank you for pointing it out. It was a very similar thing in the other thing. It's kind of surprising that happens, but
Okay.
yeah. So just go to the next one. It's true, right? It's
Yeah.
back.
No, I moved on because I couldn't figure it out. But
Okay. Yeah, maybe I'll make note of to send that in. This is module 3, right? Module 3.
yeah.
Okay.
And then I want to say in
Yeah.
the first test, and this is like super simple, it was either the first or the second test, I can't remember. But it was where they came out with, I feel like I did everything and I studied for everything, and then all of a sudden it was like, which graph properly represents, the function of b or g or the function of f, and I just was like, I don't remember this at all.
Okay. Let me see if I can find that real quick.
Yeah, a couple of those were a little.
And I didn't even know.
You really had to think about it.
Yeah, I just was not prepared for that. I don't know. I didn't have a place where I knew where it was at.
It's something about a graph. Is that what you said?
Yeah, I don't remember what test it was in. Maybe the second one.
Maybe this one. This is a question about graph. Is it about continuity? Those are often graphing questions.
No, it was just it might have been the next test. It was just like just randomly, hey, you're, how do you graph this function? And I was just like, I have no idea how to graph that function. I don't feel like I learned how to graph this function. But there was no
Okay.
numbers in it. It was just the function.
Sure.
Are you looking for me? It was Lambert. Yeah, I've been struggling so hard in this. So
This one.
Oh, I think I got this wrong too.
What's the question? Consider the graph of y left of x. Maybe your answer. Drag the movable black point to a point where the derivative is -1. Is that this question?
that might have been it. Yeah. It's been so long that I don't even remember hardly. I don't think I probably got.
So is that saying that the slope is -1, right?
Yeah. So it looks like maybe I can't interact with this one, but it looks like maybe there was a slider. You could slide this thing around,
Yeah.
and you had 1, 2, 3, 4, 5 options. And
I probably that would be +1 then.
this one right here would be up 1 over 1, 2, 3, 4, 5.5 or something. So this would be like a 1/5 slope. So it looks like it was this one, right? Because this one's down 1 over 1, down 1 over 1. So that's got the -1 slope.
I got you. I wouldn't have got that anyway. I didn't like that question alone. I think I was so new to calculus at that point. The question alone, I was just like, okay.
Yeah, that's the kind of thing that you might get in an algebra class, right? So slope, right? Like you might be confused about slope in general, and their rates of change and derivatives are heavily reliant on the concept of just knowing what slope is. And so that's sort of a stumbling block, then it prevents you from getting to that higher stuff.
Yeah. Okay.
But yeah, so that's one of the things we talk about is derivative means instantaneous rate of change. It means slope of the tangent line. So if you draw a line that just barely touches the graph, just one spot like this one,
yeah,
the slope of that line kind of represents how steep the function is right there.
Yeah, and I feel like I get it better now, but it's hard. I guess I sometimes, even though I might understand a function, if I see it in algebraic terms, translating that randomly to a test without seeing it. I don't know if I saw it before, but translating that to a graph out of nowhere must have been where my confusion was at.
Sure, no, I understand.
Because see, I was even on the positive side on that. I didn't even go negative on it.
Gotcha. Yeah, I think this is the same one, but negative would mean it had it pointing downward.
Yeah, and I went positive. So yeah, you live and you learn.
That's right. That actually looks like it should be at 0 slope. It looks like it's the top, but maybe not. All right, what else? I'm gonna pull up some more material. I posted examples.
Hold on, let me go to the last thing I was learning.
Yeah, I'm kind of just stuck on week 4 stuff. Yeah, I mean, I have one specific one. If Jacob, if you
No,
don't.
go
have
ahead. Go
one.
ahead.
Yeah, this one's question 7 in the week 4 mastery exercises. To use the inverse function theorem to find a specific point given the original function, and note that t of 0 equals -8.
Okay, I was just looking at this inverse function theorem, so it'd be good to
Yeah,
have this pulled up.
yeah, I need some more work on this one.
So what this is saying is like, this is kind of a complicated looking expression, but it's saying like, if you want to differentiate the inverse, it's the same thing as 1 over the normal function differentiated with the inverse plugged in. So this is kind of, this kind of notation is what I was trying to help us understand a little bit before, right? It's the inverse plugged into the derivative. And so just like being able to see that and understanding the difference, and if we had a function, we could use this kind of information is ultimately what we want to be able to do. How do we feel about inverse functions? This is the kind of thing that Jacob's probably like, oh man, I wish I had that other class about inverse functions. We could talk maybe quickly about that. Maybe I'll pull up this question that Jasmine asked, and then I will use it as a segue to talk about inverse functions. You said it was in 4. Is this one number 7?
Yeah, number 7.
Yeah, so this is the kind of like, when I'm looking at this, it wants you to take the derivative. This is all notation. I totally get why it's confusing, right? This apostrophe means take the derivative. And we're taking the derivative of the inverse. So we want the derivative of the inverse, and then we want to plug -8 into it. But all we're being given is the normal function. So it's like, well, how are we going to get the inverse? Well, maybe we could maybe try to solve for it. Or this thing just tells us that we don't actually need the inverse, right? If you just want the derivative of the inverse, you can just plug the inverse into the function itself. Let me do my little inverse segue. And we even have this information right here. Is this a typo here? No, do not include T inverse in your answer. Oh, I forgot the answers right here too. Let's talk about inverses real quick, because I don't know, maybe this will help with Jasmine's understanding as well. A lot of the time, we talk about plugging things into functions. And it equals some number, right? And so f lives over here in the domain. We take x values, and they get sent when you plug them in over here into f to something else. And the thing they get sent to, we call the range. And so this right here would be in the domain on the left. Pen back, that's in the domain. And it gets sent over to the range. You can think about it as x and y values. When we get into higher level math, it might be more inputs than just 1 and things like that. But for our understanding, plug in an x, you get out a y, right? Domain and range. You can think about that as like x values and y values. Inverses send them back. So the inverse would take that same y value and send it back to the x value. It kind of like undoes the function in some sense. So for example, f is square root of x. When you square root things, right? The inverse of f, what do you think? What's undoes square roots?
Squaring it.
Squaring it, right? So if we plug something into f, like f of 4 is square root of 4, which is 2. If we wanted to get it back to 4, we would have to square it. F inverse of 2 equals 2 squared equals 4. So that's just sort of like the concept of what an inverse is. Only certain functions have inverse. You need to have one-to-one functions, but they're relatively important, because if a function telling you something, if you want to undo it, then that's what the inverse does. And so that's how they have these weird relationships that is coming in this particular function. So can I clarify something about that? Does that seem okay?
Yeah, I'm good with that. So then in this particular problem, are they saying that 0 is the inverse of -8?
I'm trying to get this is the actual question, right? This isn't part of the explanation. It says note that T0
T of
okay,
0
yeah.
equals -8.
Right. So the basic kind of inverse questions that you see in pre-calc classes, let's talk about that real quick. If T of 0 equals -8, that means that T inverse of -8 equals 0, right? It sends it back to where it came from. And so ultimately, we're trying to find T inverse of -1. I mean, of -8. And so this is not what we want, but this is what gets used in the formula, right?
Right.
In other words, we're not using the thing we're giving us, we're using the concept. Let's flip back over here real quick. Let me clear this out. And we'll apply this rule. Right. So right now what we have is this. We have the inside part. We have F inverse of 0, or was it 0, 8? I can't remember. F inverse of one of them equals the other one, whatever I just wrote down.
F inverse of 8 equals 0.
Right. Thank you.
Yeah.
So this is, this is the inverse function theorem. This is just literally this right here with the 8 plugged in, right? And we know what we just wrote down was, since T of 0 equals 8, T inverse, I keep losing my pen, T inverse of 8 equals 0. So right here, this changed to 0. See that?
Yeah.
And T prime of 0, I'm sorry, I think I said inverse a couple of times. T prime means we're taking the derivative.
So right now we're just taking the derivative of that.
Exactly, and that's an easy one, right? So T was a nice easy power rule. Let me scroll up and remind myself what it was. It was the minus x cubed minus 8x minus 8. I'll try to remember that. It's minus x cubed, not 8x cubed. I just did it again. Right, that was T. And so then T prime is a nice easy power rule.
Yeah.
Which ends up just being -8.
Right, because then we plug the 0 in. So that ends up in the bottom.
Oh, so it's really just the inverse of the derivative of the original function.
Yes, does that always happen? Is that what this property is telling us though?
Yeah, 1 over, so you just turn it into a F prime and then you put it under a 1.
I think that's a coincidence in this case. I mean, it both comes from the constant right here being on the end, but there's not always going to be a constant hanging out at the end that ends up being that. So I think that's a coincidence. It's an application of, I would describe this again as being something that's more complicated than it really is, right? It's all about understanding the notation that's in this box, right? It's knowing like what the inverse means, using it so you know that T of 0 equals 8, T inverse of 8 equals 0, like that. that one little step. If you didn't know what the inverse was, you would miss that one step probably. And being able to kind of what I sometimes call just like following the instructions. And I don't mean that in a rude way, just like it's telling you to do something, and whether or not you understand the notation is really what's the barrier in getting it right. It's not like some high level concept that's tricky. It's the notation and it's tricky. Don't get me wrong. It's not like it's easy, but that's the problem. I can't get rid of that t0 equals 8. We can look at it again though. So, just look at this expression. This is sort of what we're looking at, and that's exactly what they're applying. And again, we really needed to know this. You're given this, and we needed to then make the jump that this happens.
Yeah.
Because that's what goes inside right there. Right?
Yeah. I guess I'm just seeing it as really, I mean, yes, but you're also taking the derivative of whatever the function is and evaluating it at the inverse, like taking that inverse number.
Yes. No, absolutely. Yeah, right. No, I mean, that's exactly what it says right here. You're right. This is what you're pointing out, right?
Yeah.
Yes.
Okay, I think we're saying the same thing. You're just saying you got to know where to put the numbers.
Yes.
And I'm just trying to understand, like, okay, if that's the inverse, we're just evaluating that number as a derivative.
Correct. Yeah.
Of the
Sorry.
original function.
What you're saying is absolutely true. Yeah.
Okay. Well, I think that's my last question.
Okay, and I'll just emphasize again, like these are, I would describe these as the more involved, kind of complicated questions. So not that you shouldn't try to understand them, but like if you're following what we're saying right now and making these connections, I think you're in pretty good shape is all it feels like.
Hey, I mean, those are the ones that I kind of got wrong consistently. So yeah.
Well, I'm glad we can sort of chat about them. Sometimes these quick talks can straighten those things out. What about you, Jacob? What else would you like to see? I'm happy to if there's some stumbling block that was preventing you, we can talk about something.
For let's see, I've got some pretty thorough notes. Let's see, I've got some pretty good notes, I think, on everything, along with I've got kind of a cheat sheet with all the different formulas, right? So like, I've got a constant power sum difference, constant multiple product, etc. I guess is it just me, or whenever we add trigonometry like cosine, secant, all that kind of stuff, do the answers just get, like, I feel like, and I don't know if I got them right or not because I didn't check, but I feel like my answers, well, just in general, whenever I'm dealing with those, are those answers always super long, or is it just me when we're doing derivatives when it's cosine x, tangent x?
I would say it depends on the problem. Some of those specific rules can get pretty tedious for sure.
Okay, so it's not okay.
And
because I feel like maybe I'm doing this right, but this is so long that it surely this answer is not going to be like all of this is what goes through my head. I've done it wrong, but I guess
it would be good to know maybe what you're talking about, because I'm wondering if maybe the question and the problem, like, for example, a product rule can get long if you have product rules inside of product rules. All of a sudden it becomes like the size of a page. So it could, in theory, but it might not have to do with the trig is what I'm saying. It might have to do with
I only really felt like it happened to me on the trigonometry ones.
Okay. So I will say those usually end up being trickier.
Okay.
And longer, more involved rules oftentimes.
And so can you, so on the, and when you're doing it, I was reading from I don't know if it was Khan Academy or someone else. I was watching somebody else do them, and they were putting all the X's in parentheses. And so and on the test, does that matter, or how does it, what is it asking for? You know what I'm talking about? Like a cosine X or.
Yeah, I guess I'm not super familiar with the way these things look and
So are you talking about the inverse of trigonomic?
Yeah. When
I think he's just in general talking about like if you're gonna put in cosine of X, do you do cosine parenthesis X parenthesis,
yes,
or
yes,
just do cosine X?
that's right. That's exactly what I'm asking.
Gotcha. All of those were multiple choice, I think. So I just picked the one that was
I
close
thought there was,
to what I thought the
okay.
answer was.
Maybe I'm just remembering.
So I see them in parentheses here.
Oh, I assumed you were talking about like the arc cotangent of x raised to the 10th power. Like, what's the derivative of that? Those are kind of long because they have definitions for all those. Or am I way off base?
Oh, that is correct. Okay. No, I don't know. That looks right then. Okay. I just had a question about that. I had a question mark on my notes about that. And so
I mean, in theory, in practice, it doesn't matter. But I understand sometimes like computer systems want things certain ways. I would say if you got one wrong, I'd be happy to mark it correct if that
I
was
don't
the reason
think,
it got
I don't
wrong.
think, I generally don't go back and check them. I'm usually like, my stress for the week has reached its peak and I just want
Sure.
to.
No, I understand. But I think it's worth noting what we sort of found today, which is
Mhm.
when you go back in, like this one right here, right? You didn't get this one right. There's usually an explanation. Sometimes they're longer than others. This one seems pretty brief, for example. But
Wait,
that
one
could be
wasn't
good
right?
for studying for the midterm, for example, right? I didn't get this one in the mastery. How do they do that? Sometimes there's good help there. Sorry, were you gonna say something?
Nothing. Go ahead. That's all right.
That's all I was gonna say. Yeah.
Okay. Yeah, inverse was almost a complete stop for me. So this has been really helpful.
Good. Yeah, I'm glad. Yeah, this is a trickier module for sure. Right, like look, these ones
Oh
get
yeah.
longer.
Yeah, I was
They're
talking about
that's
those.
just the way they are. Can't get around those.
Okay, so it's 50 questions and we only get 5 hours.
I think that's the setup, I believe. Yeah.
Okay.
I mean, that's a long time.
That doesn't seem like a long time to me at all. It's only 6 minutes a question.
Wait, you were in my pre-calc class, weren't you?
I was, yeah.
Did your my midterm just completely just turned off and I lost everything and I about had a heart attack.
No, that didn't happen to me, but I benefited from being able to retake that test because I did not do well on the first one.
Our midterm just stopped. Like mine, I probably had 3 questions left and it just shut down.
They were having lots of like technical difficulties that term, if I remember correctly, weren't they? I wasn't teaching at the time, but I remember getting all these emails about things.
Yeah, it was. I thought I was gonna have a heart attack. I was so sad. I think I'm good. Is there, from what you've seen on this